Let's get started. Today we're going to start by giving a little warm up, getting a little started, getting our inequalities all set for this time. So let's do a little review. Take a few moments, pause the video when you're ready, and go ahead and answer these 6 questions. Come up and write the inequalities or graph the inequalities for these 6 statements. All right, so let's see what we came up with. So we're gonna I'm gonna circle just to make our let statements a little easier. So we're gonna say let x equal the pay here. So x equals, okay? So we're gonna say, so this one says no less than. So it's not less than, it's gonna be greater than or equal to. So x is greater than or equal to $9. Can they make $9? Yes, they cannot make less than $9, but they can make $9. The maximum number of students, so that's really what we're looking at, is students is our let x right here, right there. Okay, so x has to be less than or equal to 18. All right, Justin needs to hold his breath for more than 45 seconds. So we're going to say it's time to hold breath. It doesn't really have time, but we're going to put breath, hold time, we'll put that right there. X is going to be greater than 45. It says more than 45 seconds, so we're going to not include 45. Okay, so our next one, I'm going to graph the first one up here, number 4. And remember our graphing process, we go ahead and graph one in the middle, and then we go one higher and one lower. Now it doesn't matter, it doesn't have to be, it doesn't have to be 4 and 6. It can be any numbers higher and lower. Use your imagination, have a little fun with it. So it's less than 5 with an open circle. The next one right here, we're gonna have as y is, we got 12, I'm gonna say 10 and 14. So we're going to say greater than or equal to, this time it's a closed circle going to the right. All right, and then the capability of our 5 cameras shown in this table. Right, inequality to describe the zoom capabilities of all 5 cameras. So we're going to say let x equal our zoom capabilities right here. And we're just going to shortcut this. So x can be greater than, or sorry, not greater than, that's completely wrong. Okay, less than or equal to 20. Okay, now we can't just say, so one of the things we talked about in class is we can't say x is less than 21, because then if we say less than 21, technically 20.5 is also correct. And so all the rational numbers between 21 and 20, everything's south. So all the fractions, all decimals. If it's people, we could say that, because then you can't be a partial person. But if it has the ability to have a rational or to have parts, then that would be the difference. Okay? All right, let's go ahead and get to today's lesson. Today's lesson really looks like our next little thing right here is solving one-step inequalities. So this is actually really similar to what we did when we said like x plus 3 equals 4. Okay, just like we did here. The biggest difference is I'm going to change this sign, and the answer is going to be different. So the 2 biggest differences are the sign. I might have greater than or less than, or greater than or equal to, or less than or equal to, as the exact same style. But what's really going to change is the answer. Okay, so let's get to it. Our goal is that we can do all 4 types at once. Okay, and do that little bit, add, subtract, multiply, and divide all the way throughout. So let's take a look and solve these. So we're going to graph each one to continue practice our graphing. So I'm going to rewrite this. So x plus 7 is greater than or equal to 10. So we go ahead and we solve this one. We say, okay, well, we solve it just like an equation, just like it would be x plus 7 is equal to 10. We're going to solve it the exact same way. So how do I get rid of a positive 7 with our negative 7? And we do it to both sides. Thank you to properties of equality. X is now greater than or equal to 3. So we'll graph it with 3, 1, and 5 here. Greater than or equal to, I've got a closed circle going off to the right. That's my equation. All right, go ahead and pause the video and try your n plus 2 is less than 8. All right, so it's just like our last one. Use our negative 2 on both sides. N is now greater than 6. So we'll put 6 here, 7 here, and 5 here. This time it's an open circle going to the right again. Now, what happens if I switch it to subtraction? Nothing changes, really, except instead of using subtraction as my inverse operation, I'm going to use addition. So how do I get rid of a negative 3? with a positive 3. So x is now less than 12. So we're going to have our 12 here in the middle. We'll go 14 and 10. So open circle, going to the left this time. All right, your turn to give this one a try. Go ahead and pause the video and see what you come up with. All right. So same thing we did earlier. Y minus 3 is less than or equal to 4. So we're going to use a positive 3 to cancel the negative 3. Y is less than or equal to 1. Sorry, not 1, 7. Oh, can't believe I made that mistake. No, that happens. Mistakes happen. We just have to make sure we learn from them. This time it's equal to, but it's less than or equal to, just like the last one. Now, what if we change to multiplication? Oh, multiplication. Oh, big difference. No, not a big difference. Except we use, instead of using addition or subtraction as our inverse operation, we're going to use division as our inverse operation. And I want us to continue to practice to write our division like a fraction symbol. Helps us think about division as pretty much just fractions. So 45 divided by 5 is going to be 9. So this time x is less than or equal to 9. So if we have 9, let's go with 1, and we'll go all the way up here, 8 more to 17. Why not? This time it's a closed circle, again pointing to the left. All right, your turn to give this one a try. 3x is less than 21. All right, divide both sides by 3. I get x is less than 21. No, that's not right. X is less than 7. Slow down and take your time. I'm talking to myself here. You guys probably did that just right, and I messed it up. So we have open circle, and again, we're going to go towards the left because that's less than. So think about this. It says everything down here, the answers, all these answers are technically correct. It makes a statement true. So anything smaller than 7 will make that statement true. From 6.5 to 3 to negative 95 would all make this statement true. All right. Now with division, again, it's the same idea. We use our inverse operation. And again, we're going to get used to writing these, thinking about these as fractions. So we're going to multiply by the reciprocal of 1 over 8. It's going to be 8 times 8. Cancel out. Times 8. X is now greater than 24. So, okay, we got 24 here in the middle. Let's go 30, and we'll go by multiples. So we'll go 18. So we're going to say, all right, it's greater than 24. All these answers would be considered correct, all the way until you decide to stop counting. All right, go ahead and give yours a try. All right, so if we have x divided by 6 is less than or equal to 7, we clear it by multiplying both sides by 6. And be sure you're showing this step to show both, otherwise it is not correct. So this time x is less than or equal to 42. It's going to go this way, but I'm going to go ahead and put my lines in so I know which way less than is. 40 and 44. Yep. All right, the last thing we're going to talk about is word problems. Laverne is making bags of party favors for each of her 7 friends attending her birthday party. She does not want to spend more than $42 on party favors. So you need to write and solve an inequality to find the maximum cost of each party favor bag. So the first thing we have to do is go, okay, let's find our let statement. Let x equal, in this case, find the cost. All right, cost. Okay. And now we're going to say, or the max cost, we'll put max up here just so we have our next little piece. What are we doing? We know the max cost is 42. No more than that. Not more than that. So we know not more. Okay. We know that. So I need that part. 7 friends. And we see the word each. So 7, each person takes a party flavor. So 7 times the cost. Now, yes. Can I spend $42? Yes. Can I spend less than $40? Yes. Can I spend more? No. So I'm going to say it's less than or equal to, divide both sides by 7. X is less than or equal to $6. So yeah, and we're going to skip the graph on this one. We don't need to worry about graphing this one. So any answer from $0 to $6 would be an acceptable an amount to spend on these party favor bags. Yeah. All right, it's your turn. Pause the video and help out Rami. All right, Rami is taking his 3 friends to a baseball game. He has no more than $24 to spend on snacks. Write and solve the inequality to find the most he can spend on snacks for each of them. So there's actually 2 answers I'll accept on this one. So let's get started. So X equals the cost of the snacks. Okay. There we go. S on that. There we go. So we know that 3 times X has to be less than or equal to $24 because he only has $24. Divide both sides by 3. X is less than or equal to 8. I would also accept 4x. Now some of you are going, oh yeah, that's exactly right. Others are going, well, how would it 4? Well, don't forget Rami is going to have some food too sometimes. So it just depends on how you want to think of it. And either one would be accepted. X is less than or equal to $6. So it could either be $8 for just his friends and he doesn't worry about eating, or $6 and he spends some money on himself. All depends on how you want to look at it. The last little thing I just want to talk about is how does this change? How does this differ from our solving equations? Well, the only way it really changes is the answer. The range of answers change. Instead of it just being X is equal to 6, it's every number less than 6 is okay. From 0 to 8 or 0 to 6, depending on what the answer is, it gives you a range of answers, not just a single answer. So that's the biggest difference we look at on these. Tomorrow we're going to be working on 2-step equations, 2-step inequalities. Have a great day.